All right, time to review some quadrilaterals. So first we got some properties of quadrilaterals. Hopefully you're getting these down pretty good. And let's see what we got. If it's a parallelogram, we got 5 things true. We know the opposite sides are parallel, opposite sides are congruent. The opposite angles are congruent, consecutive angles supplementary, and the diagonals bisect each other. All right, how about the rectangle and the rhombus? So all the angles are 90 degrees. The diagonals are congruent. That's a big one. This is the definition. This is a theorem. And in a rhombus, all the sides are congruent. That's the definition. And the diagonals are perpendicular, so this is 90 degrees. We just said all sides are congruent. And the diagonals bisect the angles, so they cut these angles in half. Okay? Those are useful to know, especially if we're trying to find all the parts of a rhombus there. So, all right. How about an isosceles trapezoid? So we have one pair of parallel sides, if it's a trapezoid. And then we have, so since it's isosceles, we got one pair of congruent sides. So we really should take this, and you know what? The fact that it's parallel, that's because it's a trapezoid. So that's one pair of congruent sides. One pair of parallel sides and one pair of congruent sides. That makes it isosceles. The diagonals are congruent, and these base angles are congruent also. Okay, so that's what's true in a isosceles trapezoid. And what's next? Let's see. How about a kite, our last little shape? What's special about that? It's got 2 pairs of congruent, or actually consecutive, sides that are congruent. And then the diagonals, one of the diagonals is perpendicular to the others. Well, they're both perpendicular, but it's a bisector, so those things are the same, of that diagonal. It's also a bisector of these angles. All right, so those things we know about a kite and isosceles trapezoid and a rhombus and a rectangle, and then parallelograms. All right, so let's use some of these things. How do we find the total interior angles of a regular hexagon? Well, our formula for interior angles is n minus 2 times 180. Okay, so this is for interior angles. All right, and so in this case, n is the number of sides, so it is in a hexagon. So we have 4 times 180, which is 720 degrees. All right, and now that's interior. Exterior, they're always the same. Remember that? So exterior angles is going to be 360. The total of all those exterior angles will be 360. Doesn't matter how many sides there are. There's 5 sides, the exterior angles are 360. If there's a million, they're 360. Now, if we want one of these angles, well, we've got to take that number, 720 for the interior, and divide it by the number of sides, 6. And that's going to be 120 degrees. Okay? If we want one exterior angles, well, they all add up to 360. So let's divide that by 6, and we get 60 degrees, which is nice because these angles are next to each other, interior and exterior, and they need to be supplementary, and those are. All right, so now we're going to get to our graphing problem. We're going to graph this and see what we can find out about it. So if we graph these points and draw it in, we should have a good idea of what shape it is. So here's our quadrilateral. We want to prove some things about it. We're going to find the slopes and the lengths first of all. And so let's actually get some letters in here. This is oops. So we have some slopes. We know AB, the slope is, we're going down 1, right 3, so that's negative 1/3. And we've got DC across from it. That slope is also negative 1/3. And then the slope from AD, we're going down 3 over 2, over 1 actually. So for AD, the slope is down 3 over 1. Okay. And for, let's see, we got BC. We get the same thing. Okay. So, what does that mean? Well, that proves that these guys are parallel because parallel lines have the same slope. So sides are parallel because of the same slope. So the sides are parallel because they have the same slope, so it's a parallelogram, but we also can check out the lengths, and if we do that, we notice that they make a nice right triangle. And so if we go over 1, down 3, we get this triangle. So if you want the length of that side, we've got to say, so if we want the length, we've got to say 3 squared, whoops. 3 squared plus 1 squared equals c squared. So this comes out to be 10. And we square root both sides, and we got our answer. So that means all sides are the square root of 10 because they're all 3 and 1 in their slopes. Okay, and so all sides congruent or equal the square root of 10 in length. Okay, so they're congruent. All right, so that means that the sides are congruent. So it's a rhombus. Okay. So it's a rhombus. All right, great. Now let's look at the midpoints. If we find the midpoints of the diagonals, careful of the midpoints of the diagonals here, and we're going to find some slopes of the diagonals. So let's investigate some diagonals. Let's come over here. Let's draw in some diagonals first of all. So here's our diagonals, and let's find the slopes of the diagonals. Okay, rise over run. So let's say we've got 1 here that has a slope of 2 over 1, so that'd be 1 over 1. Or let's just say 2 over 2, which is 1 over 1. And this slope right here is going down to the right. Oops. This slope right here, down to the right, is going down for right 4. Okay, so its slope is m equals -4 over 4, which is -1, and this is +1. So what's the relationship between these? These are opposite reciprocals. Since they're opposite reciprocals, this has to be perpendicular. And anytime we have perpendicular diagonals, that means it's a rhombus. All right? So the slopes are 1 and -1. Okay? And so that means these are a rhombus with perpendicular bisectors. Okay? All right, so we got a rhombus there. Now if we notice that if we find the midpoints, so to find the midpoints we need the midpoint formula. So let's use opposite midpoints, the ones I underlined there, these guys up here. Okay, we're going to add the x's and divide by 2 and add the y's and divide by 2. So we're going to have 1 plus 5 divided by 2. And then we're going to have the 5 plus the 1 divided by 2. These are y coordinates. All right, and that's going to give us a 3, 3. Okay, so that means that AC crosses at 3, 3. Now let's try the other ones here. Let's try this 4, 4 and this 2, 2. Where do those two lines cross? Well, we can use the other 2 here. What are they? They are 1, 5. No, we just used the 1, 5. The ones underlined in blue, 4, 4, and 2, 2. So let's average those. So we have 4 plus 4. No, sorry, 4 plus 2 divided by 2, and then 4 plus 2 divided by 2 again. Okay? And so this is 3, 3. And that's our coordinates. So notice these coordinates are the same. So since these coordinates are the same, that means the diagonals bisect each other, all right? So the diagonals bisect each other because they have the same midpoint. All right, so that makes it a parallelogram. Okay, let's cruise along. All right, next problem we're going to look at is real similar here. We're going to graph this parallelogram. We want to find the slopes and lengths of the sides, all right? So let's do that real quickly here. So we have two lines that have a slope of 1/2. They're parallel. And these other lines have a slope of -2/1. Notice these are opposite reciprocals, okay? And so that means that they're perpendicular. They're 90 degrees, okay? So all angles are 90 degrees because the sides are perpendicular, okay? So we've proven that. Now let's find the lengths real quickly here. So going up 2 and over 4 there. So 2 squared plus 4 squared equals c squared. 2 squared plus 4 squared would be 20. So c is going to be the square root of 20. Okay, so this is square root of 20, and this one's going to be the square root of 20. That means it's a rectangle because opposite sides, oh, I'm sorry, it means it's a parallelogram. Once we finish this next one here, so we got to get the short side also. So we got going over 1 down 2. So we're going to do 1 squared plus 2 squared equals c squared. And so this is going to be 5 when you simplify that. And then we'll square root it. And the square root of 5 is c. All right? So this is square root of 5. This is square root of 5. All right? And so since opposite sides are congruent, that makes it a parallelogram. Not necessarily a rectangle, but it makes it a parallelogram. All right? So, I didn't quite finish this one. All angles are 90, so that makes it a rectangle. All right, which means it's also a parallelogram. But since we just showed that opposite sides are parallel, then that means it's a parallelogram. All right, so we got it's a parallelogram, but more special, it's a rectangle. Let's find the slopes and lengths of the diagonals and see where that takes us. So there we have two diagonals in green there, and we want to find their slopes and their lengths, okay? The slopes will tell us if it's a square or not. Well, this has a slope of 0, rise of 0, and a run of 5, okay? So we've got AC has a slope of, I'm sorry, that was BD. BD has a slope of 0, and AC looks like we're going up 4 over 3. Okay, so slope of 0 for 1 for 3. They're not opposite reciprocals, so those are not perpendicular, so this is not a square, because a square has perpendicular diagonals, because it's a rhombus. Okay, but we can confirm that it's a rectangle by checking the length. So the length of this here, we've got one of them, BD, we can just count. That's easy. BD is just 5. But this AC is slanted, and we're going over 3 and up 4. Over 3 and up 4, so 3 squared plus 4 squared equals c squared. Well, that is a Pythagorean triple. You may notice that. So this is going to come out to be 25 because it's 16 plus 9. And so take the square root, and we end up with 5. Okay. So those two diagonals are congruent, 5 and 5. So since the diagonals are congruent, that means it's a rectangle. Congruent diagonals mean it's a rectangle. So we found out it's not a square because the diagonals are not perpendicular. It also means it's not a rhombus, but the diagonals are congruent, so it's a rectangle. Okay? If we know it's a parallelogram and the diagonals are congruent, that means it's a rectangle. Okay? So it's a rectangle. All right. Soon we have a parallelogram here. All right, these ones should go a little quicker. We've got AD, that's this side right here, and we've got BC, that's this side right here. And so those are opposite sides. These would have to be equal. All right, so 6x minus 4, 56. Add 4 to both sides and divide by 6. And x is 10. All right. If we know we have a rectangle now, there's no drawing here. You might want to draw it out. That's a good idea. LMJK. Okay, we're told it's a rectangle. And so we know that the diagonals of a rectangle are congruent. So LJ is one diagonal and MK is the other. So these guys have to be congruent. All right. And so we can solve this up. We got 2x plus 3. Subtract 3 from both sides and divide by 2. And so x is 2. All right? Rectangles have congruent diagonals. So if we assume this is a parallelogram and we know this D is 43 degrees, well, these have to be supplementary, right? 180 minus 43 is 137 degrees. And so these guys, 95 plus x has to be 137. We'll call this x right there. So subtract 95, and we've got, well, let's see, 42. That should be good. All right, there you have it. So find all the missing measures, it also says here. So if that's 42, let's go a little bit further. This guy is 42. Alternate interior angle says this guy's got to be 42. This guy's got to be 95. And opposite angles are congruent. Now, there you have it. All right. Okay, and so we've got a parallelogram here. YVWX. YVWX. All right. It's a parallelogram. And we got some diagonals that intersect at, come on, diagonals. See if I can draw a straight line. At this point right here, we're going to call that E. Okay? And, well, this is interesting. A little typo going on here. It says WM is 32. Okay? Well, sorry about the typo there. I think the point is for this to be an M. All right? So if that's an M instead of an E, let's make that an M. And we know that WM is 32. Well, we know the diagonals bisect each other, so YW has to be 2 times 32, which is 64. Okay? All right, one more page. Let's check it out. Got a rhombus. And in this rhombus, we know that BDC is 42. We're told that DE is 8. And EC is 6. We want to find all the missing angles and segment lengths, all right? Let's find everything. Well, we know that this is, since it's a rhombus, this is perpendicular. These are all 90 degrees in the middle. We know that since it's a rhombus is a parallelogram, so the diagonals bisect each other. So those have to be 6 and 8. Since this is a right triangle here, this guy's a right triangle, we can use the Pythagorean theorem. 6 squared plus 8 squared equals c squared. And so this comes out to be 36 and 64. And that's 100. And so we get 10. So this has to be 10. Now we were told this is a rhombus, so all sides would have to be 10, right? Okay. And then let's go find some angles. We got 42 degrees here. That's 90. Well, these three have to add up to 180. Or since this is 90, these two add to 90. And so 90 minus 42 is going to be 48 degrees. Okay, so this will be 48. We know that the diagonals bisect the angles, so that guy's got to be 48. We also know that opposite angles are congruent. So these two are 48. This angle is bisected by the diagonal because it's a rhombus. And this angle B is going to be congruent to the opposite angle D. So those are 42 also. All right, I think we got everything. So just by knowing a few parts, we can find all the parts of the rhombus using their properties. Okay, so number 10 here, we got a trapezoid. This little 8 kind of ran away. That 8 is supposed to be over here. PQ is 8. I hope you figured that out. Sorry about that. Okay, and so we've got AB is 4x minus 3, actually plus 3, and CD is 2x plus 7. We know that the, let's see, what do we know? Okay, we know that the mid segment, this is a mid segment because it connects midpoints. Okay, and so this PQ, which is 8, is the average of the top and the bottom. So we can say that 8 is the average, 1/2 of their sum. 4x plus 3 times, plus 2x plus 7. All right? And when we add up the inside, we get 6x plus 10. Distribute that 1/2 and we get 3x plus 5. And let's bring down that 8. Kind of running short on room, but subtract 5. 3 equals 3x, so divide by 3. X equals 1. All right? So that is for that part A here. Now there's a hidden one in here, that just another situation. What if we know AB, which is up top, is 9. We know PQ in the middle is 12, but we don't know this. Okay, well, we can still say that PQ 12 is the average of the top and the bottom, CD and 9. 9 plus CD. We'll just use CD as a variable. If you want to use like a Y or something, you can. Okay, and then we can distribute this here. 12 equals 1/2 times 9 is 4.5. We'll go decimal, why not? Okay, and then 1/2 times CD. Subtract 4.5. And we get 7.5 equals 1/2 CD. We want to find CD, so let's double it to get this 1/2 out of there. And when you double it, you get 15 equals CD. Okay? And that's our answer here for this little guy. CD equals 15. All right? 2 more. So we've got a pentagon here. Remember, we got to first find the total degrees in the pentagon. So the pentagon is 5 minus 2. The formula is n minus 2 times 180. So we have 5 minus 2 times 180. That's going to be our total degrees, and that equals to all of these added up. Okay? All the interior angles add up to, in this case, 540 is what that will multiply out to. And so we got 3x plus, what do we got? 252, 256, and that would be 336. I think that's right there. So if we subtract from both sides, 540 minus 336 is going to be 204. And if we divide by 3, well, 3 times 60 is 180. And this is like 180 and 24, so I think we're looking at 68 degrees. Okay? That's the idea. One more. We talked about some limits in class. We introduced the idea of a limit when we talked about some regular polygons. And so when we have regular polygons, we can have, remember, regular means all the sides and angles are the same. Okay? So, well, let's see. I'm trying to draw. If we were to kind of go around and start making a regular polygon, okay, not very good, not very regular, but if we could make all these angles the same, we have an exterior angle here, and we have an interior angle here, okay? I might call them X and Y. All right, the exterior angles will all be the same if we can actually draw perfectly. That's what computers are for, right? And all the exterior angles add up to 360. We found out that the exterior angles, for one of them, would be 360 divided by n. All right? So that's one of the angles. So the question we talked about is, We asked, what is the limit of one exterior angle as we get more and more sides? As this gets to be 100 sides or 1,000 sides or 1,000,000 sides. Well, this guy is going to go away because the more sides we get, the smaller this little angle here is going to have to be, right? And so this n is getting bigger and bigger, 360 divided by 100, 360 divided by 1,000, 360 divided by 1,000,000, and so this is going to 0. Okay, it'll never quite be 0, but it's getting really close. So we say that the limit as n goes to infinity, so as we get infinite sides, is 0 degrees. Okay, so that exterior angle is going to 0 degrees. That's called a limit. It never reaches it, but that's something good to know. All right, and the interior angle, by the way, is going to, if that's going to 0, what's this interior going to? Well, this guy's going to 180 degrees, right? Because those angles are getting bigger and bigger if it's a regular polygon. Okay, so there you have it. All right, hope that helps. Keep studying, keep working hard.